The surface area of a spherical balloon is increasing at the rate of 3 centimeters square per second. At what rate the volume of balloon is increasing when the radius of balloon is 5 centimeters? So this question is taken from application of derivatives, and this can be solved by using rate change. Here is a rate is given, so we can solve this question by using rate change. Before proceeding, let me clear the concept of this question. Whenever we are blowing a balloon, its radius is increasing. When the radius of the balloon is increasing, then surface area also changes. Surface area also increases, as well as when the radius of the balloon is increasing, its volume is also increasing. So how fast the volume is increasing, that is the question. So rate change nothing but, for example, ds by dt nothing but rate of change of surface area, rate of change of surface area, and dv by dt is nothing but rate of change of volume, rate of change of volume. V is the volume. Volume of spherical balloon is given by formula 4 by 3 pi r cube, where r is the radius of the balloon, and surface area of the balloon is given by 4 pi r square. Now, so ds by dt, rate of change of surface area, dv by dt is the rate of change of volume, and one more thing, dr by dt nothing but rate of change of radius, rate of change of radius. So we are going to deal with these three derivatives, that is rate change of surface area, rate change of volume, and rate change of radius of the spherical balloon. So we have ds by dt gives differentiation of surface area with respect to time, and dv by dt gives differentiation of volume with respect to time, and dr by dt gives differentiation of radius with respect to time. For spherical body, surface area given by S equals to 4 pi r square, and volume is given by V equals to 4 by 3 pi r cube. In the question, the surface area increasing at the rate of 3 centimeters square per second is given. In the question, ds by dt is given to us. ds by dt equals to 3 centimeters square per second. Call it 1. Now, since we have S equals to 4 pi r square, differentiating with respect to time t. So differentiation of S with respect to t equals to differentiation of 4 pi r square with respect to t. Since S depends upon r and r depends upon time, as the time is changing, the radius of the balloon is also changing. So ds by dt, that is differentiation of S with respect to t, 4 pi constant as it is, and derivative of r square is 2r, and derivative of r we need to do once again because r depends upon time. So dr by dt. So this is equals to ds by dt, that is nothing but 3. So in place of ds by dt here we can write 3, because ds by dt equals to 3 centimeters square per second. It is already given in the question. So 3 equals to 4 pi multiplied by 2r dr by dt implies dr by dt equals to 3 divided by 8 pi r. Call it equation number 2. Now the volume of the spherical body given by 4 divided by 3 pi r cube, and we want to find out the rate at which the volume of the balloon is increasing. So we need to do derivative of v. So differentiating here, differentiating with respect to t. So we get dv by dt, that is differentiation of 4 divided by 3 pi r cube with respect to t. This is equals to 4 divided by 3 pi as it is. Derivative of r cube is 3r square. Again dr by dt because r depends upon time. So we have dv by dt. Call it equation number 2. So we have the equation 1. Call it equation number 3. So we have the equation 2 and 3. Now putting the value of 2 in equation 3. So putting 2 in 3 now. So we get dv by dt equals to 4 divided by 3 pi multiplied by 3r square, and dr by dt nothing but 3 divided by 8 pi r. So dv by dt, that is the rate of increase of volume of spherical body. Now if any cancellation, cancel them. 3 and 3 cancelled. Pi and pi get cancelled. R and R get cancelled. What is left? 4 multiplied by 3. 4 and even this cancelled. So we get here 3 R divided by 2. We have to find out the increase in volume, rate of increase in volume when R equals to 5 centimeters. So now putting R equals to 5 divided by 2, 15 divided by 2 equals to 7.5. Therefore, rate of increase in volume of sphere at R equals to 5 centimeter is given by dv by dt, differentiation of v with respect to t at R equals to 5 centimeter, that is equals to 7.5 centimeter cube per second. Friends, let us test your understanding. To test your understanding, I have given you one question as a homework. The surface area of spherical balloon is increasing at the rate of 4 centimeters square per second. At what rate the volume of the balloon is increasing when the radius is 3 centimeters? Dear students, what should be the next question? If you have any difficulty, please let me know. I will certainly help you and solve your difficulty. Meet you again with next question, next topic. Till then, keep on enjoying. Bye bye. See you.